All right, we're going to do example 4 in increments of 15 degrees so that we can really see what this is doing. So we're definitely going to need a calculator to help us here. And if you want to do it in degrees, you're going to need to use a calculator in degree mode. So sine of 0, well, sine of 2 times 0 is 0, times 5 is 0. 15 degrees, if I take whatever answer my calculator gives me to, oh, you know what? Here's why we're doing this in increments of 15. What's 2 times 15? 30. So we're actually doing the sine of 30, which is 1/2. And then half, so that's 2.5. So we can still do a lot of these in our head, even though we're doing increments of 15, because of the double angle. That's the whole reason I was doing this in increments of 15. Sorry, I forgot about that. Okay, sine of 2 times 30, so sine of 60 is square root of 3 over 2 times 5 gives us approximately 4.3. And then sine of 2 times 45, so that's 90. Sine of 90 is 1 times 5 is 5. And then the sine of 2 times 60 is 120. The sine of 120 is 4.5 times, did you get 4.3 for that one? We're going back down, right? Okay, and then we have the sine of 150, which takes us back to 2.5. And then the sine of 90 times 2, or the sine of 180, which is back to 0. Just for fun, let's graph what we have so far. So 0, 0, and then 15 degrees is 2.5, and 30 degrees is 4.3, 1, 2, 3, 4.3, and 45 degrees is 5, 1, 2, 3, 4, 5, and 60 degrees is 4.3, 1, 2, 3, 4, and a little bit. And then 75 degrees is 2.5, 1, 2 and a half. And then 90 takes us back to 0. So again, remembering that when you graph these, you're going in order. So you're hitting all those points and going back to 0. We now have the petal of a flower. And this flower is, they call it a rose, even though it looks more like a daisy. The official name that's been given to it by the math community is rose. But we were going to have 3 more petals. And so quadrant 1 gave us petal 1, happens to be in quadrant 1. Quadrant 2 will give us another petal, but I think that the quadrant 2 petal is going to end up in quadrant 4 because we're going to have negative numbers. And then, yeah, should we just go for it and see what happens? I can just basically give you the numbers I have, and then it'll just go a little faster. The numbers are kind of just going to repeat here, but because it's 105, that means it's 210, which is in quadrant 3, so that's negative, so that gives us a negative 2.5. 120 is 240, so that's going to give us a negative 4.3. 135 is 270, so that will give us negative 1 times 5, which is negative 5. 150 times 2 is 300, so that gives us negative 4.3. That's a 4. Just say them out loud. Yeah, so 105 is negative 2.5, 120 is negative 4.3, 135 is negative 5, 150 is negative 4.3, 165 is negative 2.5, and 180 is back to 0 because it's 2 times 180, which is 360, which is 0 times 5, which is 0. Okay, so then let's graph those. So 105 is this line right here, but it's negative. So we're going to go back 1, 2. Wait, it's 2.5, isn't it? So right there. Okay, and then 120 is this angle, but we have a negative radius, so we have to go backwards. 1, 2, 3, 4. Here, I should really erase this point so it's not confusing me. I don't know how to erase easily without picking the eraser and erasing. There we go. All right, and then we have a negative 5, so 1, 35 goes backwards to -5. Is that right here? Did I count? 1, 2, 3, 4, 5. Yes. And then our symmetry falls into place, so it'll be there, and the petal would be graphed. Remember, this one came around and went here. These are kind of fun to watch them graph, like in an IT calculator, if it doesn't, like, I don't know if you've ever watched graphs graph on a graphing calculator, but it actually, you can watch it go into place. Anyway, there's different settings you can use for that, at least with the older calculators. Okay. Do you see what's happening? Do you want me to fill in the last two quadrants, or should we just make a guess of what's happening here? Maybe I'll just kind of skip some of the major ones. So we went back to 0, and we're going to go to 195, which takes us to 2.5. I'm going to go ahead and skip to 2, can't read my handwriting, 225. Yeah. Okay. I need to not try to do things different, just stick with what I'm doing. Okay, so 210, 225. My line is too big to fit. 240, 255, 270, 285, 300, 315, 330, ugh, 345, 360. I gave us more than enough spaces that it would just repeat again after that. Okay, so then our numbers just repeat, 4.3, 5, 4.3, 2.5, 0, -2.5, -4.3, -5, -4.3, -2.5, 0. Sorry, my handwriting turned out horrible on some of those. Okay, so 195 is 2.5, and then it goes to 4.3, and then 5, and then 4.3, and then 2.5, and then back to 0. So there's that loop. And then the last one is 285, but it's negative, so it goes back to here. And then 300 goes to here. 315 goes back to here. 330 would go backwards to here. 345 would go backwards to here. And then 360 goes back to 0. So following that last set of points, we get our 4-petaled rose. So you can see here on our reference page, if there's a 3 times the theta, you get 3 petals. If there's a 2 times the theta, you get 4. Yeah. Yep, perfect. So A is the length of the petals. So the fact that there was a 5 there, that's why our petals were 5 in length. If the coefficient of theta is odd, like it is here, then we get an odd number of petals. So like if we had a 5 theta, we should get 5 petals. But if the number next to theta, the coefficient of theta, is even, then the number of petals doubles. So if we did a 4 theta, we should get 8 petals. Yeah. It might be, it depends on if it's an R squared problem. Is it an R squared problem?